Hello, millennials and Gen Z. In previous videos, we have seen the model with single neuron and two neuron. Now we quickly have a look into the model with 20 neurons and two hidden layer. One hidden layer contains 10 neurons, other hidden layer contains 10 neurons. So overall this model is same. Like equation is y equal to 2x, it's going to satisfy. So the data is accordingly that 1 into 2 2, 2 into 2 4, 3 into 2 6, and input is x, as you can show in the below diagram. Input x goes to the 10 neuron, then 10 neuron have the connection with next hidden layer of 10 neuron, then finally it creates the output. Gradient error, everything is going to be the same. Okay, so let's jump into the code. Top section is the import section. Here we define the model class with two hidden layer of 1 connect with 10 hidden layer connect with another 10, then from 10 there is one output. So forward is arranged like this. Hidden 1, we pass the value to the hidden 1. After the activation function generates the output, then this is going to the second hidden layer, generates the output, then this 10 goes to the output layer and generates single output and return. This arrangement gets done for the model. Now instantiate the model, define the same loss function as we see in the last two videos, define the optimizer with a learning rate 0.01. This is our data with which we are going to train our model. Yeah, so let's run up to here quickly. This gets run, this gets also run, done. Now we looking into here is training of the model. So we see first the initial weight and then the final the weights over here from the output layer, how the weights get changed. Now these 20 neurons weights and biases are now responsible to generate an output. Combination of these neurons are responsible to generate the output. Let's run it. So we can see over here initial weights are like this. Definitely it's as the neurons increases, it's hard to manually track the weights of the neurons. So let's first look into the first neuron only, how this value is going to be changed. So it's initially all the weights get randomly initialized, then after that, after training, every neuron weight adjusted to the appropriate value. So here minus 0.07, after that it is 0.14, 0.13. So it's first increased to 0.14, then decreases to 13, 1344. Okay, it gets optimized as per the training goes on, right? Similar with all other weights. So finally it gets trained, and we can see the loss also over here. The loss is with the initial randomized weights, the loss is 0.047. Then the loss reduces. You can see the loss gets reduced iteration by iteration, but we can see an interesting thing, like after 200 iteration loss is this, and after 300 iteration loss is negligible, and after 400 iteration it's perfectly fit into the model. This equation y equal to 2x perfectly fit into the model, and the result is like this. And these iterations are of no use. If we run 500 iteration as well, 400 iteration as well, then it will perfectly fit the equation over here. In testing, if we take the value 6, now as per the equation 6 to the 12, so here the value needs to come as 12. Let's run it. Yeah, it's near to 12, 11.94. So that's the training. That's the training with the that's when we are training with that, it it reaches to the nearest value, but not exactly that value. That may be possible with the model. So let's suppose if we test with 12 to the 24, 24 needs to come over here. Let's see, 23.76. Okay, model gets trained, but still it has some it is not as perfect as we try to look. But yeah, this is the case with the model. Now here the main thing is that all the neurons collectively responsible to generate this output, they all need training, they all need their appropriate values, through which, through calculation of which this results get generated. So now up to here, we see the example with single neuron, 2 neuron and 20 neuron. Why we go in that sequence? Basically to understand a concept which is very important going further, to understand the transformer model. So basically here we get the output. Suppose in initially when we give some value over here, and suppose here the output comes as 15, but the expected output is 10. So error is 15 minus 10, because we need over here is output needs to be 10, but the output comes as 15. So 15 minus 10 is 5. So error is 5. Now the error is 5, that's okay, that's no problem. 5 is the error. Now we need to adjust the weight such that this error will not come. Instead of value 15, value 10 will come over here. So we need to subtract some number from each neuron, right? So that's the biggest doubt for me, or problem for me, like how do we know from which neuron what number needs to be subtracted? I can also do like, if we need to, here we get 15 but we need 10, right? I can adjust the single neuron only, and then we get the here correct value. But know that all the combinations of this needs to be adjusted. Combination of this and this needs to be adjusted in such a way that this error 5 gets corrected. So the hero of our story comes out to be the gradient. So the value cannot be changed randomly, or we cannot change 3 values and get the output, 3 neurons and get the output. So what value we need to change in all these neurons is determined by calculating the gradient. Now what's the gradient? As we always say, gradient is the rate at which error gets changed on the change of weight, W. So once gradient calculation is very important when we are understanding the neural network and the training of the neural network, and it will follow up to the transformer model and very advanced model as well. So we take the example of single neuron, 2 neuron and 20 neurons only to understand this concept of why we need gradient and how gradients works into the system. Calculation of gradient is another topic that we are going to cover in future video, but we give all this time and all these efforts, all these videos, just to know the importance of gradient and the basics of learning, what the learning mean. And now we can visualize learning means what, and how the weight gets changes and affected the whole working of neural network model. Now the base, now once the base gets clear, our base gets clear, going forward we always talk in a high level mode, not at this level. So this level needs to be concrete before we move to the transformer model. Now we are talking into the high level only, like back propagation, gradient, learning rate, and all that things. We don't now we don't always deep into the this level of details. So if you're still not clear with this detail, go through the video many times you want, and concrete concrete the concept of gradient and learning in your mind. Then we move to the understand transformer model, on which all advanced AI based upon. Thank you very much. Have a good day.